Welcome to Spring LIB.
So for this problem, we're given the solubility product constant for copper 1 iodide, and we're asked to find E0 for some other reaction. Well, copper 1 iodide dissolving, this is a redox reaction. And this equation here is the reduction half reaction. So let's just start looking at what we have. We have KSP, and for every redox reaction, there's an E0 for that reaction, which would be the sum of the oxidation potential and the reduction potential. So what we're solving for is the reduction potential, which is given by this equation here. And you might be thinking, well, we don't have E0 for the reaction or E0 for the oxidation. So how are we going to solve for E0 reduction? Well, for KSP, we can get to E0 reaction, and that's from the relationship with delta G, which we'll look at that in a moment. But what about E0 oxidation? We're not given that. Well, if you could find the oxidation reaction that goes with the reduction of copper iodide, which is, again, this equation, if we knew that reaction and we knew its oxidation, E0 oxidation, then we'd be all set because we have E0 reaction and we'd have E0 oxidation. We would just need E0 reduction. And so the equation that we would need to add to the copper iodide reduction is this one. It would be solid copper being oxidized to copper +1. And that reaction is given in table 18.1. Now, the thing is, it's given like this. I'm circling here. It's given because that's a reduction table. But all we have to do is flip that reaction around, and E0 goes from positive 0.52 to negative 0.52. So now, if we add these two equations together, we arrive at the solubility equation. And so we can just add the oxidation. Well, if we add the oxidation and reduction together, now we have E0 oxidation. We're going to solve for E0 reduction, and that equals E0 for the reaction, which we're about to get from delta G. So we're basically all set to solve for what was asked for in the problem. So delta G is equal to negative NF E0, and that's also equal to negative RT ln K. So we can set these things together here. So NF E0 equals RT ln K. In this case, it's going to be E0 for the reaction is equal to RT ln KSP, because that's what we're given, over NF. And so we plug those numbers in. We have our R value in joules per mole Kelvin, the temperature, because we're at standard conditions, 298 K. There's KSP, 1 mole of electrons. And again, that's if we look at its copper plus an electron gives you copper. That's the equation that's in the table. So it's just 1 mole of electrons. And it's the same if you look at the copper iodide reduction. It's just +1 electron, so we don't have to balance out any electrons. So this gives us negative 0.1 joules per coulomb, and joules per coulomb is a volt. So those are the proper units. So this is E0 reaction, which can also be sorted a different way. This is E0 of the reaction. So now we plug in our numbers. Negative 0.71 equals negative 0.52 plus E0 reduction. So just doing the algebra, that gives us E0 reduction of negative 0.9 or 0.19 volts.